Thank you. Good afternoon. My name is Fred Schwartz. I'm with Kimley Horn and Associates. I am from Chicago. This is actually a view of our office down the river there. And Chicago is a great place to live, very walkable place. I actually raised my hand to each of your questions about what I find outside of my home, which is an apartment right on a great street. Chicago is also home of the Bears, and as well as the home of the 1908 World Series champion Chicago Cubs. And if you're a baseball fan or a Cubs fan, or a Red Sox fan for that matter, you'll know that we just hired Theo Epstein as our president of baseball operations. So what he did with Boston, we're hoping for in Chicago, except that last choke part right at the end. Chicago is also the home of other well-known personalities and caricatures. But for this group, it's the home of great streets. It's the home of walkability and density. And this is Michigan Avenue, a couple blocks from our apartment. And Mark probably knows these numbers better than I do, but I've always said that Michigan Avenue carries 30,000 trips a day, vehicles a day, and 30,000 pedestrians a day.
I think it's even skewed higher.
It's 44,000.
Yeah.
All at the same time. And so as we walk in our neighborhood, my wife and I will think, wow, this would be a great place to live. And so what I kind of the overall subject that I'd like to consider today is great streets. And maybe only a small hand grenade thrown in the room is the names of things that we talk about to get to great streets. We do have complete streets. We have context-sensitive solutions for streets. I don't hear traffic calming much anymore, but that's what I think we used to call it. So I feel like we need a new name, and for this I'll call it Great Streets, because it's all about creating communities, livable communities, and I think in our profession, our contribution to that has to be the street infrastructure. So I'm here to talk about another ITE manual. I'm actually a fellow in ITE. I was a member when they called it the Institute of Traffic Engineers, and we moved on since then. This is the manual that was started several years ago. When I first used to go to CNU conferences, Congress for the New Urbanism, it was a good 10 years or so ago. And my training is in traffic engineering. And I felt like I had to wear dark glasses whenever I went there because that group was lambasting traffic engineers as the root of all evil. And the fact that 5, 8 years later, whatever it was, ITE partnered with CNU to create this document is huge. And I'm actually pretty proud of ITE for taking steps like that on this manual, which has been submitted to ballot, which I guess the Networks manual is about to do or is in the process of. So it's not even a proposed ITE recommended practice anymore. The membership and other interested parties have provided comments. It is an ITE recommended practice. One of our goals in creating that document was to have it on every public works and traffic engineer's desk throughout the country so that when we go in there we can say, see, it is possible. There's nothing in this document that violates the American Association of State Highway and Transportation Officials, otherwise known as AASHTO, criteria. And so this, like the Networks book, I think is one that we'll be able to waive and distribute. It is actually available for free online. And I don't know whether that's because it's past the final version. So, so maybe hold out for the free version on the networks.
No, please do not. Just get somebody in your city to pay for it.
Well, okay, then I'll offer to get you copies for $50 and make $5 on each one. The ITE Designing Walkable Urban Thoroughfares, a context-sensitive approach, is broken into these three major categories, and chapters fall into those categories. This context image that you've seen, I think, a couple times already this afternoon is one of the foundations of the document. It talks about organizing our system of thoroughfare design around these context zones of different kinds of urbanity, or from rural to suburban to urban. And the document itself is applied in only these 4 zones. It's not applicable in the rural zone. One of the quotes in the document is that thoroughfare design changes as context changes. And I think that's an important aspect of this. And that the thoroughfare both responds to and contributes to shaping the context and defining the place. And so it's a chicken and the egg kind of a relationship. So most of you may be aware of this document and its use in designing the thoroughfare, the facility. But just to bring everybody up to speed, let me go through that part of it quickly, and then I'll back out and look at the planning and the network aspects of it. The document identifies 3 thoroughfare types. Not included in the document are local streets, residential local streets, or the expressway. These are only thoroughfares, kind of that middle range. These are the components, the thoroughfare components that are varied with the context. They include the traveled way, which is the street that we usually think about, but also the street side component and the context itself, which would be outside of the right-of-way. So this is an example of a boulevard. Boulevards are 4+ lanes. The target speed on a boulevard is 35 miles per hour. One of the terms that was debated a lot in developing this manual was that target speed, that is the speed that we're targeting drivers to drive at. The boulevard is mainly for longer trips, for freight movement. It's where access to property is managed in an effort to move the longer trips. Parking can be found on boulevards, but not always. The avenue is a step smaller. It is a 4-lane maximum facility. Its target speed is 30 to 35 miles per hour. Has much more focus on land access. This is where you can find local transit, local deliveries, and curb parking is common on avenues. And then down another step is streets, where it's 2 lanes maximum and the target speed is 25 miles per hour. The street is much more about land access, connectivity. The great commercial streets are typically in this street category to serve land use. And the street side zones, we talk about the width and function of the zones, and it's meeting the ADA requirements and providing a pedestrian buffer, as well as other amenities, plantings and public art, and this is where places are created in the street. And so this is the matrix. It's the manual's written by engineers, so we have to have one of these complicated matrices. But you can see the 4 categories in the middle are the street types that we've talked about, and at the top, we're not talking about freeways or expressways. I actually glossed over the multi-way boulevard, but it's a type of boulevard. And so we've got boulevard, avenue, and street, and across the top, those criteria that I listed quickly of number of through lanes, operating speed, the kind of transit, the kind of parking that's appropriate on each of those thoroughfare types. So with that, let's dive into the network aspect of this. As I said, the planning part of the manual is broken into kind of a process. How do you go about doing this? And then a discussion on networks and corridors. And it talks about creating walkable places as being an examination of all of these levels of streets, the network, the regional, the corridor, and then all the way down to the street facility. Because challenges encountered creating more walkable urban thoroughfares can be resolved at the scale of the network or corridor. I think we very often find ourselves arguing about an issue on a street when that argument ought to be on a bigger issue about the network. Where should the throughput be? Where should the bikes be? It goes back to this balanced, layered networks. And so considering network design and function can lead to solutions that balance between demands for vehicle throughput and support for adjacent development. And you covered this great about prioritizing and emphasizing the various modes on each facility. If you look at the network, then you can make those decisions about which parts of the network ought to satisfy which of these elements. A bit more about network types, covered great by Ian earlier. These images are the traditional network. It's about connectivity and alternative routing, block size, and the conventional. And as you can see, this arterial, you can just imagine what it does to the network around it. It's literally impossible to cross this except at mile spacings where the traffic signals are. There are no left turns across it, let alone pedestrian crossings. And so if you have this kind of a facility, then the rest of your network is going to be impacted in more of a conventional configuration. So the differences in networks, we've talked a lot about block size, connectivity, some about degree of curvature. There's some discussion about how good networks need to be straight. I'm not sure I agree with that, but they do need to be connected and small block sizes. I'll go over this quickly and would love to come back to it in Q&A or in discussions later. We've talked about some of these indices of how good a network is, but they've been reduced to ratios to actually test and compare networks. And so, as I said, I'd love to come back to this later and talk about these indices, how they're calculated and how we get to them. So when considering network design, properly located express thoroughfares supplement the urban arterial thoroughfare by providing high-speed, high-capacity service for longer trips. The guide goes into this in some detail to say not all streets should be 2 lanes, low volume, low speed, that there is a role for these higher expressways, but their role needs to be identified. And in the planning portion or the corridor portion, these are the kinds of traditional steps that you'd go through, and I won't cover any more of that. So if you've had enough of the gory details, I'd like to go through a few case studies, one in Madison, Wisconsin, one in Richmond, Virginia, and one in Minneapolis, Minnesota. So how many people are from Madison? I know at least one. Oh, a couple. Good. You'll know the site. Hopefully you know the project is going on, and I know some of you have been involved in helping identify the network in Madison. It is the state capital. Probably the capital of a number of things, isn't it? Demonstrations and recall elections, and farmers markets. That's true. It is great farmers market. This is the layout. Madison is an isthmus, and so for you geography buffs, you know that's a narrow piece of land between two bodies of water, and they are two Great Lakes. Well, not capital Great Lakes, but they're really wonderful lakes that separate, that create this isthmus, and it's a John Nolan design plan of great visibility and sight lines. This is our site. Madison, I guess like other cities, likes to number their blocks, and so we've got Block 88 and Block 105. And on Block 88 is what was built as the federal courthouse. And Judge Doyle actually presided there. That's the name of the project. But I think it was in the early 70s when it was converted to a municipal building and city offices moved in there. So that's on Block 88. And this is Block 105. This is Government East parking structure, and doesn't follow the John Nolan architecture, but is like early 50s grotesque architecture. So the plan is to combine those two blocks and recreate the parking below ground in 4 or 5 levels of subterranean parking, and then create a developable parcel on Block 105. And so you can see again in this plan view how that might work. The municipal building is off to the left here. That would definitely be preserved in one use or another. Parking would go under the 1.5 blocks, and then this block would be opened up for redevelopment. I will have a bike station. Mobus Bike Planning is looking at the feasibility of a bike station in this facility. And so again, looking at the aerial view, that's our site. This is the Capitol Square, and it operates in a counterclockwise one-way fashion and is for bikes and buses and open to cars, but not meant for carrying large volumes of traffic. And hopefully you can see the blue square on the outer loop, which is 2 or 3 lanes of one-way traffic and is meant to provide circulation and throughput. One of my Madison guys is smiling.
I was a grad student in Madison, and the first time I tried to actually drive through there, I went around, I think, 2 times. Once shot out that way, once shot out that way, and it took me 45 minutes to drive 1.5 miles, and I gave up in disgust, went home and got my bike.
That's when you became a bike advocate? No, it is. Once you get going, it's, and there are diagonal streets, and yeah, it's fun. So as you could see, our site is located on the outer loop, which is, at least in the downtown Madison, the throughput street. I mean, it's not a freeway by any means, but so our challenge is going to be, and we're in the process, this is a very early part of the process, but is our challenge as a part of coming up with a conceptual plan for these 2 blocks is to handle this one-way outer loop in an appropriate way, connecting the square to the bike. I failed to say that there's a great bike route path along the lake here, so connecting that with the existing street infrastructure and providing bike connectivity and pedestrian connectivity, and connectivity to the convention center, which is the Frank Lloyd Wright icon you can see down at the bottom of that axis there. Comments from the Madison folks before I go on? I actually think there's some debate among city folks about where bikes should be.
Why? I shudder to think how much 5 underground levels of structured parking will cost per car. Who's bearing that cost, and how is that cost being justified in light of, well, I presume Dave Chislovich is still the mayor, and he isn't. Oh, okay, that's why there's 5 layers of underground parking. Never mind.
It's actually the mayor that was in office when they bought the municipal building in the early 70s. He's back again.
What's the cost per space, and who's bearing that cost? And is that actually being made explicit, or is it kind of being hidden and folded into the project? Because that's got to be ridiculously expensive, and it doesn't seem appropriate to a core urban context like this where you want to be promoting transit, not driving.
I knew I shouldn't have asked for questions in the middle of the presentation. Well, no, I'll back up enough to say that there is a hotel planned on half, either this part of this parcel or incorporating the municipal building into a hotel. So there is some development potential. There are 600 parking spaces in the structure now, so they've got to go somewhere. The alternative would be, in an urban context, to build another above-ground structure. And then there's the development potential and the parking needs for what might come on Block 105. One of the things that initiated this project was the need for parking for the high-speed rail station, which was planned here, maybe here, which, thanks to the governor, is not going to happen, at least in his term. So it still needs to be worked out. The funding obviously has not been determined. We're doing a concept planning exercise. This is the Route 5 corridor study. And Route 5 starts in downtown Richmond and travels through Shockoe Bottom and through some fairly rural areas as it leaves downtown, as it leaves Richmond and moves into Henrico County. One of the first steps that we took in this corridor study was to organize the project using the transect zones. And so you see on the left, here's the transect concept. We applied that concept to the zones along this, I think it's a 12, 13 mile corridor, and then converted those to context zones. Pretty much a one-to-one correlation between the two in order to organize the planning and design of each of the pieces of the corridor. A big part of this corridor is the Virginia Capitol Trail, which runs along the river. Well, it's actually just being planned now along Route 5. And so it truly was a multimodal corridor study because that bike trail was already in the planning stages. And bus rapid transit is in the planning phases for about the first third of the corridor in the downtown and through Shockoe Bottom. There were 3 transit alternatives, depending partly on the context and the ridership. At this point, I probably need to say that this rural-looking area on the previous aerials, that there are some, or were some significant projects planned there in what's called Rockets Landing, drawing a blank on the names of the others, but they're going to come up. Along that corridor, lots of residential development. Tree Hill and Wilton, multi-hundred and thousand acre developments. And so I want to focus a bit on the roadway concepts because in the In the red zones there in the downtown, we were not looking at adding lanes as much as making the most of the lanes that we had in terms of BRT, in terms of time of day management kinds of things, signal timing and parking. It's that center brownish zone where a lot of the alternatives were developed to find ways to add network capacity, because in the southern, or as they say in Richmond, the eastern zones, the roadway concepts are not nearly as involved. So this shows a little bit about the kinds of considerations that we had. One of the, we looked at peaking of traffic throughout the day, very steep peaks right now. But in the future, we expect those to flatten out some as land use changes. And the image on the bottom right there is one I wanted to talk about just a little, because it is from, I first saw it at Purdue University in Traffic Engineering School, and go back to it from time to time. It is the speed flow curve. And what you've got along the bottom, it wasn't nearly as graphical when I saw it in college, but we have simplified it a bit. On the horizontal is flow in vehicles per hour, and the vertical axis is speed. And so as you start out with zero speed, you gain in the amount of flow you can handle, but only up to a point where it starts to double back, that at 50 miles an hour, you're carrying the same amount of traffic as you were at, oh, I guess it would be out here, as you were at 10 miles an hour. And so the whole concept that let's make the thoroughfare faster so we can carry more traffic is a fallacy. And if you stand beside the road, which we traffic engineers do all the time, and watch traffic go by, I think you'll realize that at slow speeds, those cars don't go by very quickly until you get up to 30 miles per hour. But then faster than that, the following distance starts to increase. And if you stand next to an interstate, or maybe over an interstate would be safer, they're not, a new car doesn't come by very often. When they do, they're going fast. But so I know there was a session earlier about speed, and maybe we can come back to this in some of the discussion about how speed enters into the design of our networks, let alone our thoroughfares. So these are some of the concepts that we came up with in this corridor study, again, in the CBD, pretty much maintaining what was there. The next segment is called Shockoe Bottom, and we're maintaining the network as well as the curb-to-curb distance and looking at using that distance in a more optimal way. But it's this rocket zone where the alternatives were really developed. This street network that you start to see here is the beginning of a pretty good TND, traditional neighborhood design development called Rockets Landing. Right on the river, some pretty good 4, 5, maybe 6-story densities using existing brick buildings, and as you can see, the beginnings of a downtown street grid and network. And so the challenge was to look at the context that was creating and recommend adding capacity in the corridor consistent with that. And so this shows a little bit about the alternatives that we looked at. And basically they were to improve this part of the corridor, and when I say improve, Ian Lockwood would give me a hard time about that because he doesn't like that word. Widen the corridor, improve it for motorized vehicles, or would we widen it over here? And I realized that this is already 4 lanes and then just kind of stops. And so there was some attraction to saying, well, let's make the rest of it 4 lanes to lead up to it and maintain what was already there in Rockets Landing. So let me clip through a couple of these. We also looked at using Wharf Street, which was the street right down on the river, to carry some limited local traffic. The Rockets Landing folks did not like that option. So these are the two concepts. The one on the left, the yellow line shows widening the current Route 5 to 4 lanes through Rockets Landing. And the big drawback from that, or the big cost of that, is a major railroad bridge. Forgot to mention that the railroad comes through here, and you can see the railroad yard that widens out there. So that was one concept, not a cheap one though. And then the other concept was to use Williamsburg Avenue 4-laning, here shown in purple, and extend that 4-laning to be the throughput roadway and maintain this narrower purple line over through the Rockets Landing area. But we also have to get across the railroad there. So again, this project is underway. We're nearing the time at which we need to select alternatives and recommend and allow the project to go to the next phase. Quickly about the transit alternatives that were also a part of the work. And the last few context zones as you move what looked like south. In the Tree Hill, more of a boulevard type use in the last two zones. So now, if I can, I'll move to Minneapolis. Any folks from Minneapolis? Just like to know who might be out there, who might be a client or a concerned citizen that's going to jump up when I say something. This is Granary Road. And this is the Hubert Humphrey Dome in downtown Minneapolis. This is the current LRT and the extension, the new Central Corridor light rail between Minneapolis and St. Paul, which is like over about here. I don't know whether you can see the light blue line that comes through here, but that is the University of Minnesota bike trail, and this is the university and their football stadium. Have they won a game yet this year? Oh, sorry. So one of the streets leading into this area is a transit bike facility, only buses and bikes. This particular section of it will become the LRT alignment. And the other end is this great bridge over the mighty Mississippi, but very poorly connected. So this is the no-build option. The reason for the study is to look at these land uses on the university and elsewhere, and how better to connect those and make them more viable. Because, again, another railroad, because of the railroad there, those uses are way underutilized and not very well connected. This is the rest of the corridor. This is what you might call the natural bike part of the trail. And all the streets are up above, a grid network of streets up above. And so we're looking at ways to use this corridor in the correct context to both connect streets and improve the trail. So one of the options would be just to connect these streets in the eastern portion of the zone, because that's where some of the immediately viable industrial uses might be. The next option would be to continue that road, Granary Road, through the rest of the area, opening up some of these uses as well. And then this red line would be non-motorized vehicles, so bikes and peds and others, because that connects over to the other great stone bridge across the Mississippi, which is shown there. Beautiful, gorgeous, clear day, except on that bridge where the falls are kicking up the mist, so it looks mistier than it was in the rest of the city. This is the full build. which uses the whole corridor for cars, but within context, certainly providing for bikes and peds and other uses. And really some of the discussion is starting about what else to use that trench for, because you saw how kind of abandoned it was. Do we just want a road through there, or are there other opportunities to create great places in that new corridor? Again, that project is about halfway through the planning process. So now that you've seen how it works, we'll open it up for questions. Yes, sir.
Well, actually, we'd like you to explain a little more, idly, how it works. Maybe take this Richmond case. How did having those different classifications of roads make a difference? Because we could have skipped all that stuff that you gave in the introduction and simply said, we want this to be 4-lane or 2-lane. But I'm sure could you explain more of how you used, do you want it to be more like a main street, or more like an avenue, or like a boulevard? More how did that context help clarify what the alternatives were and help lead to good decisions or whatever?
Great question. It definitely provided a vocabulary to use with not only the city officials and VDOT, who is a stakeholder, but it definitely provided that way of talking to the public in public workshops, and provided a way to say, yes, it may be 4 lanes, but don't think about 4 lanes in a standard way throughout the whole corridor. That a 4-lane avenue is different than a 4-lane boulevard. And it allowed us to talk about the different modes of travel which needed to be, which are going to be and needed to be in the corridor, and the different ways to handle that, because the Capitol Trail doesn't follow the street throughout the whole corridor. And so providing for it in the southern end of the corridor was quite a bit different than how it was handled in the downtown and in that western Shockoe bottom area.
Just one more. Like in the 4-lane sections could be either avenue or boulevard. The main difference, if I understand right, being restriction on access. So was that part of the planning that that either zoning or some kind of restriction on access was part of the options and not part of one alternative, not part of another?
In the CBD and in the Shockoe Bottom zones, access was or is at streets and at closely spaced blocks, and so the avenue is much more appropriate for that existing grid. In the other context zones, though, the developments to come, or at least that were on the board a few years ago, did not address Route 5. In fact, they turned their back on Route 5 and created their center somewhere else. And so I wouldn't say we were advocating controlling access, but I would say that there was no access needed, or that it was at least a different level of access in those areas. And so the boulevard was more appropriate for that. Yes, sir.
Do you associate certain bicycle facilities with each of those types of systems? For example?
With each of the thoroughfare types?
Yeah.
Yeah, I think on these thoroughfares, if you look just at the thoroughfare, it's assumed that the bikes are in the right-of-way and have to be handled in that way. I think that's one of the advantages of looking at these layered networks, of saying that bikes are allowed on those streets, low-speed streets with parking, but they're also provided for elsewhere. And so, at least in Richmond, we accommodated bikes on all of those segments, but on those where there were no bike lanes, there was a parallel trail or a parallel facility. Yes.
Also on the Richmond project, is this under environmental NEPA document?
This study is really before that. I think that would be the next step in the process. Our charge was really to identify concepts from a traffic capacity standpoint, but as well from a land use standpoint, and I would expect that that would be one of the next steps that it would go through. Yes.
In the Richmond study, when you have the two alternative routes, and I'm sure y'all had, or plan on having a public input sort of process with that, but were you considering, aesthetically, or I guess, which route would be more pleasing for pedestrians and bicyclists when selecting the two alternatives, just from a land use and aesthetic standpoint?
Yeah, the pedestrian generator is definitely Rocket's Landing, and so that's where the higher activity is going to be. It was one of the criteria that we looked at in both cases, and pedestrians will be provided for in both cases, but based on adjacent land uses, both current and in the long-range plan, the level of those facilities ought to be different because of the land use that's there. Yes.
You said in an earlier slide that talked a little bit of some of the measures of connectivity. You said you might be able to go over it in more detail.
These are identified in the ITE book. I think Ian mentioned them as well, or lots of different sources for these. The first one is links and nodes, and so it's simply dividing the number of links by the number of nodes. And so it's the number of street segments divided by the number of intersections, I guess you could say. And as you do that, if you can come in between 1.4 and 1.6, that would be a desirable level of connectivity. The next one is intersection ratio. Is this a definition that you use? Intersections divided by intersections plus dead ends. I'm not sure I've used that one before, but that's one that was listed. The next one is much more common. Well, intersection spacing, obviously, that's block size. How big the block ought to be, the shorter the better, but 400 to 600 feet. Maybe we can debate that if you'd like to. But the intersection density is the one that you talked about. Intersections per, in this case, square mile. It could be something smaller than that. Does anybody have a feel for what a high level of connectivity would be?
Well, leading to east is 400 as kind of the max, but in Portland it's much higher than that, 200 by 200 square foot block.
Yeah, so in Portland the blocks are 200 feet on each side, so that's a lot smaller than the intersection spacing requirement, and so therefore the intersection ratio goes way up. Blocks per square mile, kind of a similar metric. And then this one, directedness, actual distance. So the directedness ratio is the actual distance, as the crow flies, divided by the travel distance. We saw some classic images earlier of how you have to go in a cul-de-sac neighborhood to go a quarter of a mile. And so if we can keep that down, I mean, ideally it would be 1.0, but 1.5 is considered desirable. And these kinds of indexes are available from a lot of different sources. And I think they're most useful in comparing. I'm not sure they're as useful in rating a network, but in comparing two networks they are. Or in thinking about how to improve the network.